We're going to start talking about linear equations and graphing now in chapter 3. So first we need to define a linear equation in two variables. We talked about linear equations in one variable in the last chapter. But a linear equation in two variables is an equation that can be written in the standard form ax plus by equals c, where a, b, and c are real numbers. A and b cannot both be 0 for the same reason we talked about before. If a and b are both 0, then we have no variables. We have 0 equals some number, and unless c is 0, that makes no sense. So a linear equation in two variables describes the graph of a line. So the next thing we need to talk about is graphing. So we're going to talk about the rectangular coordinate plane, which is also called the Cartesian coordinate plane, named after French mathematician and philosopher René Descartes. So the plane consists of two number lines that intersect each other at right angles at their 0 coordinates. The vertical axis is the y-axis, so we put the values of the y variable on that axis. The horizontal axis is the x-axis, and we put the values of the x variable on that axis. The location where the two axes intersect is what we call the origin. And that's labeled over here on the graph. It's right smack where they intersect. And those two axes divide the plane into 4 quadrants. The quadrants, as you can see, are labeled using Roman numerals, and we start with the top right quadrant and we move counterclockwise. So the top left is quadrant 2, bottom left is quadrant 3, and bottom right is quadrant 4. So every point in that plane is described by the distance along each axis that the point lies from the origin. And we do that using what we call ordered pairs. So the ordered pairs are represented by the notation x, comma, y. So the x, the horizontal variable, always comes first, and the vertical variable always comes second. So the origin has the ordered pair 0, 0. And it lies on both the x-axis and the y-axis. So let's practice by plotting the following points and identifying what quadrant or axis they lie on. So point A, let's do this in blue. Point A is -2, 5. So that tells us starting at the origin, we go to -2 on the horizontal axis, and then we go to 5 on the vertical axis. So the point is right there. And that's point A. Okay, which quadrant is that in? Well, remember, we start at the top right and move counterclockwise, so that should be quadrant 2. If we plot B, we have 3, -4.5. So we go horizontally to 3 and then down to 4.5. So that's about halfway between 4 and 5, so about right there. That's point B. That one is in quadrant 4. Okay, point C is 0, 3. So 0 means we don't go anywhere in the horizontal direction. We stay at the origin, but we go to -3 on the vertical axis. So that point is right there, point C. So that is on the y-axis. Okay, I think you guys should pause the video here and try to do D, E, and F on your own, and then you can restart the video and see if you got it right. So D is -1, -1. So we start at the origin, left 1 and down 1. So it's right there. And that is in quadrant 3. Point E is 5, 0. So we go to +5 on the horizontal axis, and we don't go up or down at all. We stay at 0 vertically. So it is right there. And that point is then on the x-axis. Okay, and the last point is point F. It is at 3, 2. So horizontally to +3, vertically to +2, and that is our point F, which lies in quadrant 1. Now, I could have told you where any of those points were without having to actually put them on the graph. How would I have known that? Well, if we go back up to our image in the box here, we have quadrant 1. Everything in quadrant 1 is a positive x and a positive y. Everything in quadrant 2 is a negative x and a positive y. Quadrant 3, both coordinates will be negative. And in quadrant 4, x is positive and y is negative. So that's one way you can check. Now, everything on the x-axis is going to be a number, comma 0. It could be a positive number or a negative number. And anything on the y-axis is going to be 0 in the first coordinate and number in the second coordinate. So that's how you can check without actually having to plot the points. We'll pick up with the next page of the notes in the next video.